Hello everyone. So now we will discuss about Kruskal's algorithm. How to implement that Kruskal's algorithm. That part we're going to discuss. So you know that what do you mean by spanning tree? Okay. So if you'll see the spanning trees is nothing but it is a subset of graph G which has all the vertices covered with minimum possible number of edges. Okay, which will going to cover all the vertices with minimum number of edges. Hence, the spanning tree does not have the cycle and it cannot be disconnected. After that, how to calculate how many spanning trees are there? So, how many maximum number of spanning tree is possible for complete graph, that we can calculate. Here you can see that we can calculate by using n raised to n minus 2. If I'll say that n is equal to 3, where n is nothing but vertex, how many vertices are there? So if I'll say that n is equal to 3, okay, n is equal to 3 means which indicate that 3 vertices are there in the given graph. Let's say that this is the graph. Okay, here on slide you can see here n is equal to 3 vertices are there. Then how many possible spanning trees are there, that we can calculate by using n raised to n minus 2. So as n is equal to 3 means 3 number of vertices are there, 3 square 3 raised to n minus 2, 3 minus 2, so that will become 3 raised to 1 means 3 spanning trees are possible for the given complete graph if n is equal to 3. And here you can see this is first spanning tree, this is second spanning tree, this is third spanning tree. If I'll say that n is equal to 4, then how many spanning trees are possible, where n is nothing but number of vertices. So if the given graph having 4 vertices, then total n raised to n minus 1, that is nothing but 4 raised to 4 minus 2. So that will be equal to 4 square, means 16 spanning trees are possible. So out of those 16 spanning tree, we are interested to find out minimum spanning tree. So what do you mean by minimum spanning tree? If the given graph is weighted graph, means weight is assigned to each and every edge. So minimum spanning tree is nothing but the tree which has the minimum weight than the other spanning tree for the same graph. Okay, that has the minimum weight other than the all remaining spanning tree of the given graph. And here in the real world situation, the weight can be distance, traffic load, fuel, or maybe in terms of price, anything. Okay, so that weight is assigned with the each and every edge. Let's say that I'm going to draw one graph. This is the graph, okay, which will having 4 vertices A, B, C and D. These are the 4 vertices are there, and let's say that weights are nothing but 1, 2, 3, 4. So here if we can say that where one is nothing but the fuel, one is nothing but distance, one is nothing but time taken from A to B to reach from A to B. B to C will require 2, let's say that 2 minutes time, 2 hours time, whatever it may be. So that is weight. And with the help of minimum spanning tree, we are interested to find out the subgraph of the given graph, such that it will give the minimum cost. There are 2 algorithms are there to find out the minimum spanning tree. One is Prim's algorithm, another one is the Kruskal's algorithm. And here you can see time complexity of Prim's and Kruskal's algorithm. So for Prim's it will be big O of n plus m log n, okay, where n is vertices, m is edges. And Kruskal's algorithm, for Kruskal's algorithm it will take big O of m log n. Okay. Now how to implement that Kruskal's algorithm? So in case of Kruskal's algorithm, first of all we need to sort the given graph. We have to arrange all the edges in ascending order according to their weight. If I'll say that this is the graph A, B, C, D, this is the graph, then what we're going to do, and let's say that it having some weight 1, 2, 3 and 4. These are the graph. This one is given graph, and if I'll say that this is 1. Okay, so we are interested here to find out the minimum spanning trees. First of all, we have to arrange the edges according to their weight from in ascending order. Okay, according to their weight. If I'll say that A to B, this is first edge, so weight is equal to 1. Okay, after that I need to consider B to D as weight is equal to 1. After that I can consider B to C as it having weight is equal to 2. After that I can consider C to D edge which having weight is equal to 3, and finally I can consider A to D. So I have arranged all the edges according to ascending order. Next thing is that while constructing or while creating the minimum spanning tree, I'll going to consider the edge in ascending order. So first edge is in this particular array is AB. So let's consider AB. Okay, and its weight is equal to 1. And while adding that edge in a minimum spanning tree, what we need to consider, whether it will going to form the cycle or not. So by adding A to B, it will not going to form the cycle. So next edge in this array is nothing but BD. So if I'm going to add the BD, so whether it will going to form the cycle, no, so we can add it. Next, so it's OR. Next one is we can add the next one is we can add the BC. This should be BC because weight is equal to, so we can add the BC. So if I'll add the BC, whether it will going to form the cycle, no, so we can add it. After that, next edge is CD. Okay, if I'll add the CD, then it will going to form the cycle. Here you can see if I'll add it, it will going to form the cycle, so I'll not going to add this edge. Next one is A to D. If I'll add A to D, then also it will going to form the cycle, so I'll not going to it. So here you can see we have visited all the edges, and this is nothing but the minimum spanning tree. Now we need to calculate the cost of minimum spanning tree. So 1 plus 1 plus 2, so that will become 4 is the minimum spanning tree cost of the minimum spanning tree. Okay, now how to implement it? So here I have created one graph class. Name of the class is graph, and first is nothing but vertices, character vertices with 10 and 10. What it indicate? Here I can store 10 city name, okay, or 10 vertex name, and maximum one vertex include the 10 character. Means suppose my vertex name is Nasik. Okay, so how many character I can give? Maximum 10 character. Okay, second column indicate that how many characters are there in one string, and first indicate that how many strings are there. Second matrix, cost matrix we have created because we are implementing this assignment with the help of, here we are implementing the Kruskal algorithm with the help of cost matrix. So that's why size is 10 by 10. So 10 which indicate that maximum I can store 10 vertices in a row. Okay, A, B, C, D, E. Let's say that these are the name of the vertices. So up to maximum 10 I can store the 10 vertices, 10 rows and 10 column, because adjacency matrix is there. Okay, so I can store like this. So that's why I have given name as a I have given cost matrix as a 10 rows and 10 column. Next one is number, indicate that every time I don't want to accept all those 10 vertices. There may be the case I want to accept only 4, 3. Okay, here you can see 4 vertices are there. Here you can see 4 vertices. So maximum I can accept the 4 vertices. Okay, and 4 vertex value I can accept. After that, here graph is one constructor is there which will going to construct the which will going to initialize this graph value with maximum value. After that, void create graph is there. Okay, so which will, with the help of this, we will going to accept the graph, we'll going to accept the weight matrix. After that, display function will going to display the graphs which we have accepted by using adjacency matrix. Position will going to find out the, whenever we're going to accept the source and destination vertex along with the weight, so where we should store, that we are calculating by using position methods or function. And final Kruskal algorithm methods or function will going to implement that Kruskal algorithm step by step. So let's see that first one. Here you can see constructor is there. What it will do, it will going to initialize that graph with maximum value. Cost of ij is equal to 999. It will going to initialize cost of ij is equal to 999. Okay na? So we are initializing that 10 by 10 matrix with maximum value. Okay, let's say that it will be A, B, C, D, E, F, G, H, I and J. Okay, so let's say that these are the 10 vertex. Here it will be an column also A, B, C, D, E, F, G, H up to 10 vertices are there. And here I am initializing A to A is 999, A to B is 999, A to C is 999, because 10 rows and 10 columns are there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and here it will be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I am initializing cost of 0, 0 is equal to 999, 0, 1 is equal to 999, 02 is equal to 999, 03 is equal to 999. Like this I am initializing 9 of 9 is equal to 999. So this total matrix is initialized with the 9999 value. Okay, maximum. Let's say that initially cost of each edge is equal to maximum 999. Okay. After that we want to create the graph. Now how to create the graph? Let's say that we want to we are here initially we have declared one start character array, end character array, and after that we are accepting enter the number of vertices. How many vertices are there? Let's say that number of vertices is equal to 4. So enter the vertices name, means node name. Okay, let's say that I am having 4 names of the nodes is equal to A, B, C and D. These are the 4 names are there. Okay, so where I am storing these 4 names, I am storing in vertices array. So in a vertices array, this is vertices array which will going to store the 4 name. Okay, this is vertices array and I am storing the number of vertices as 4. So let's say that first vertex is A, second vertex is B, third vertex is C and fourth vertex is D. So it will be 0, 1, 2 and 3. So vertices of 0 is equal to A, vertices of 1 is equal to B, vertices of 2 is equal to C, vertices of 3 is equal to D. After that what we want to do? We need to accept the start and end vertex edge. Okay, so enter the start and end vertex, start vertex and end vertex. Let's say that start vertex is A and end vertex is equal to B. Okay, let's say that start vertex is A, here you can see, and end vertex is B. After that I am accepting the weight from the user, enter the weight. So let's say that weight is equal to 2. Okay, so I want to accept the weight is equal to 2. So I have accepted so far start is equal to A and end is equal to B and weight is equal to 2. End is equal to B and weight is equal to 2. Now I is equal to, I am calling the method position and start. Position and start. So I'll going to call that position method. So let's switch to the position method. Here you can see in the position method, so we have passed, here you can see we have passed position as a start. We have passed the start as a vertex. Okay, and start vertex is equal to A to the position method. So here start is A. So here character key value is from that by passing it will take as A. After that what I'll going to do, I'll going to compare that I is equal to 0, I less than number of vertices, which is equal to 4 actually right now, I plus plus. So string compare vertex of I will start from 0. So vertices of 0, okay, compare with key value is A. So what is there in vertices of 0? We have already created that array. Here you can see vertices of 0 is equal to A. Vertices of 0 is equal to A. So A, compare A comma A, whether these two are equal. Here we are using string compare function. So these two are equal, that's why it will going to return 0 value. So return I, it will going to return the I. At what value? I, when I is 0, that time these two are the same. So 0 value is returned to this particular I. Okay, so start vertex A is present at 0th position. Now I want to find out end vertex position. End vertex is what? B. So B will be given. Now whenever I am going to give the B, so again it will instead of A, now key value is B. Okay, again it will start from 0 to number of vertices. So vertices of 0 comma key value is B. Key value is B. So vertices of 0 here in the array, A is there. So whether A is matched with B, here no match is found. So now I will become 1. So vertices of 1 comma B. So vertex of 1 is what? Here you can see B is there. Okay, so B comma B match is found. So at what position match is found? Whenever when the I is equal to 1. So 1 is returned to the calling part. So J will become 1. So what it indicate? Starting vertex position is 0 and ending vertex position is equal to 1. So cost of I is 0 now. Cost of 0 comma 0 1 is equal to cost of 1 0 is equal to 8 is equal to weight. So weight we have accepted 2. So A to B weight is 2, and in the cost matrix having A, B, C and D. This is the cost matrix. Okay, and number of columns is also same. So it will be A, B, C and D. So let's write down the, so row will start with, let's say that 0 1 2 and 3. This is row value. Column values are 0, 1, 2 and 3. ठीक है ना. Now what will happen? Cost of it will going to store I position is 0, J position is cost of 01 is equal to 10. 01 is equal to 10 equal to weight. So 01 is 2, weight is 2, 10 is also 2. ठीक है ना. So this is first one. So again I am asking, do you want to add some more edge? Let's say that yes. So this loop will be continued. This do while loop will be continued until we are accepting the edges. So let's say that next edge is this one, which having weight is equal to 1. So B2C, it will going to find out B2C position with the help of that position matrix, and it will going to store B2C is equal to 1. Same is the case, C2B is also equal to 1. Okay, because this one is undirected graph, so we can read it from B2C or C2B. Okay, weight is same. Next one is D2C. Let's say that weight is equal to 3. D2C, which edge is weight is equal to 3. So C2D is equal to 3, and same is case D2C is equal to 3. ठीक है ना. Now next one is, let's A to D wedge is there, A to D. So A to D is equal to 1. Let's say that 1 is there, for example. So here for this A to D, here you can see A to D is equal to, okay, so A to D is equal to 1. So I'll going to add A to D 1 and D to A is also 1. And let's say that one more edge is there, B to D, which having weight is equal to 2. Okay, so B to D which having weight is equal to 2. So B to D which having weight is equal to 2, and D to B weight is equal to 2. And remaining we have initialized with the help of this constructor 999. So remaining value will be equal to 999. Okay, so all remaining position value will be equal to 999. There is no any edge between C to A as well as A to C. Okay, same is case C to C, there is no any edge. D to D, there is no any edge. So this matrix we have created with the help of this function. Now what is next? I want to display the matrix. So how to display? Here we are displaying the matrix with the help of adjacency matrix list. So adjacency matrix list. So how to display it? I want to display, okay, I want to display this matrix in the rows and column form. So you can say that, let's say that 4 vertices are there, A, B, C and D is there, and next one is A, B, C and D. Okay, so I want to display it like this: 0th rows, first row, second row and third row. Okay, 0th column, first column, second column and third column. ठीक है ना. So that's why I have used here 2 for loop. First for loop will work for rows and second for loop will work for column. ठीक है ना. And I want to display each rows and column value new line. That's why I have given /n here. So it will going to display that matrix which you have taken previously. Okay, this matrix will be displayed as it is. So okay, 999, after that 2, 999, 1, 2, 999, and like this it will going to display with the help of this logic. ठीक है. Now important part is how to implement Kruskal algorithm. So let's consider one graph, and with the help of that we're going to implement Kruskal algorithm. So let's draw one graph. Okay, and graph is equal to, suppose, A, B, ठीक है, after that C, after that D. 4 vertices are there. Let's consider 4 vertices are there, and our graph is like this, and I'll give the edge like this. It may be something, okay, 3 and 4. Suppose this is the graph, and this one is weighted graph. So let's store that particular weight in the adjacency matrix, because we're going to store that with the help of create graph methods. So let's say that ABCD, and its row value is equal to, suppose, 0, 1, 2 and 3. Okay, and column value is also same, because 4 rows and 4 columns are there. So column names is also A, B, C and D, and which will be equal to 0, 1, 2 and 3. Okay, so it will be A to B, there is a path, so value having 1. A to B will be equal to 1 cost. B to A is also equal to cost is 1. Next, B to C is 3. So B to C cost is equal to 3. C to B cost is equal to 3. Next, D to C is 4. D to C is equal to 4, and C to D is also equal to 4. Now next one is a to d 2 is there, so a to d 2 is there, d to a is also equal to 2. Now next one is b to d is equal to 1, b to d is equal to 1 and d to b is equal to 1, and remaining value as there is no any edge, so it will be equal to 999, remaining will be equal to 999. ठीक है ना. Now we want to find out the minimum spanning tree with the help of Kruskal's algorithm. Minimum spanning tree with the help of Kruskal. Let's start with, so initially I am saying that initially I have declared some variable like total cost of the minimum spanning tree. Initially it is equal to 0, mean value is there, okay. After that gr is equal to 1 and flag is equal to 0. So what is the use of flag? Let's say that we have not visited any vertex till now, up till now we have not visited any vertex, अजून कोणताच वर्टेक्स विजिट केले नाही, सो फ्लॅग इज इक्वल टू 0. सो इफ while flag is equal to 0, until we will not going to visit all the vertices, we need to continue this operation. So flag is equal to 0, yes. So minimum is equal to 999. Let's say that minimum cost is equal to 999. Okay, so we are setting it to the maximum value. Now for I is equal to 0, I less than number of vertices, let's say that 4. J is equal to 0, j less than number of vertices 4. Now with the help of this, what we want to find out? We want to find out minimum cost among all these 16 values. With 16 value, 4 rows and 4 columns are there. So total 16 value, you can count it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Means 1, 2, 3, 4. 4, 4, 8, 4, 16. Here I am counting these 4, these 4, these 4 and these 4. Out of these 16, which value is minimum one? That we are find out with the help of this one. So if cost of 0, 1, so let's start with I is equal to 0, j is equal to 0. So cost of 0, 0 is less than minimum, initially minimum value is 999. So cost of 0, 0 is what? 999. So 999 is less than 999, this condition is false. So now j will be incremented by 1, j is 1. So cost of 0, 1. So here you need to check in this matrix what is there in cost of 0, 1. So cost of 0th row and first column, okay, what is it? 1 is there, it's 1. So 1 is less than minimum value किती minimum value is equal to 999. Is it less than? Yes. So minimum is equal to, now this condition is true, so minimum is equal to cost of 0, 1, that is equal to 1. So now new minimum value is equal to 1, and when minimum value is equal to 1, when x is equal to I, means x is equal to I means I is 0 and j is 1. ठीक है ना. Now after that let's check for all remaining value. So next j will become 2. So 02 is what? Here you can see 02 is 999, but now new minimum value is equal to 1. So this condition is false. Next time it will be 02. New minimum value is 2. Actually, new minimum value is 1 and its cost of 02 is 999. So no match is found. 03 is also 2. So 2 less than 1, condition is false. Next time is I will become 1, 10. 10 is 1, 1 less than 1, condition is false. So like this, among all these value will get this one is minimum 1. ठीक है ना. So when x is equal to 0 and y is equal to 1. So what is next one? Next I am creating one vertex v array. I am creating one v array which indicate that visiting vertex, which store the visiting vertex. ठीक है ना. So when x value is equal to 0 is there, here you can see x value is 0 is there and y value is 1 is there. So v of 0 is equal to 0. Yes, right now initially we are going to initialize all these values equal to 0. Initially means which indicate that we have not visited any vertex a b c d, अजून एकही vertex visit केलेले नाही, that's why initially it is 0. Now v of 0 is equal to 0, yes, and v of 1 is equal to 0, yes. So that's why v of 0 equal to v of 1 equal to gr, and initially you can see that gr value is equal to 1, as gr value is equal to 1. That's why v of 0 and v of 1 is equal to 1. What it indicate? We have visited that two vertex. Okay, 0 and 1 ला मी vertex visit केला आहे, and now gr value will be incremented by 1. So let's say that it will become 2, as it previously it was 1. Now because this if condition is true, that's why it will going to bypass this else if and this else part. ठीक है ना, it will going to bypass all these. Now after that, so all these parts are bypassed. Now it will jump to this one. So cost of ij x is 0 and y is 1. Cost of 0, 1 and equal to cost of 1 0 equal to 999. What it indicate? So 0 1 is here in this matrix. 0 1 is equal to 1 and 1 0 is equal to also 1. So we already visited, so let's make it as a 999. Let's make this as a 999. Okay, so next time we should not consider this as a minimum one. That's why here with the help of this I am making it as a 999. After that, minimum is not equal to 0, right? Because right now minimum is equal to 1. From where we are getting? Here we are getting minimum ची value 1 असताना आपण we have assigned minimum is equal to 1. ठीक है ना? So minimum is not equal to 0. So true. Then total cost is equal to total cost plus minimum. So initially total cost we have initialized it with the 0. Here you can see initially we have initialized it with the 0. So total cost is equal to total cost plus minimum. So 0 plus 1. So total cost will become 1 now. And now here we are printing cout vertex 0 and vertex 1 is visited. So vertex 0 is what? Vertex 0 is nothing but A is there. Okay, here you can see vertex A 0 is A and vertex 1 is B. So this line will going to print. This line will going to print vertex A and B is visited and cost is equal to 1. After that, what we want to do? We have to check whether all vertices are visited or not. That's why temp is equal to V of 0. Temp is equal to V of 0. V of 0 ची cost किती झाली आता? 1 झाली. Okay. From where we have created? Because here you can see we have created V of 0 is equal to 1 and V of 1 is equal to 1. So that too we have done. So V of 0 is equal to 1. So temp will become 1 and flag is equal to 1. Let's say that we have visited all vertices. Now we have to actually check it whether all vertices are visited or not. That's why I is equal to 0, I less than 4. Now temp ची value किती आहे? 1 and not equal to V of I ची value 0 पर्यंत start झाली. So 1 is not equal to 1 because V of 0 is 1. So this condition is false. Next time I will become 1. So temp is equal to V of 1. V of 1 is also 1. So 1 is not equal to 1, condition is false. So I will become 2. So temp value is 1. 1 not equal to V of 2. So here you can see V of 2 अजून काय आहे? V of 2 is unvisited because its value is 0. So this condition is true now. This condition is true and it will going to make the flag is equal to 0, which indicate that still we have not visited all the vertices. So again it will start from initial while loop. Okay, again minimum is equal to 999. Again we will going to check all these 16 value. Among all these 16 value, which one is minimum one? So let's say that I is equal to 0, I less than 4, j is equal to 0, j less than 4, and cost of 0 0. So cost of 0 0 is 999. Is it less than 999? False. Okay, next time 0 1. So 999. 0 2. What is it? 0 2 is equal to 2. 0 2 is equal to 0 2 is also equal to 999. After that 0 3 is equal to 2. 0 3 is equal to 3. So 0 3 is less than 2. Yes, true. Okay, because 2 is less than 99, true. So minimum is equal to new minimum will be equal to 2 when x is equal to 0. I ची value अजून काय 0 होती, but j ची value is 3. So now x is 0 and y is 3. But we have to check whether any value which is less than 2 in the remaining value. Yes, one value is there. So which is less than minimum. At what position? When I is equal to 1 and j is equal to 3. So that time x will become 1 and j is equal to means y will become 3. ठीक है ना? So at this case we'll get the minimum value when b2d is equal to 1 and d2b is also 1. ठीक है? So now again it will start here. So it will check. So right now when x is 1 and y is 3. So it will check whether v of 1 is equal to 0. X is 3. V of 1 is equal to 0. Is it equal to 0? Here we have created v of 1 is equal to 0. This is v of 0. This is v of 1. Is it equal to 0? No. So this condition is false. Now it will jump to the LC. Whether v of 1 is not equal to 0, true. This is true. And v of 3, y value is 3. Here you can see y value is 3. So that's why v of 1 is not equal to 0, but v of 3 is equal to 0. Yes, v of 3 is equal to 0 because we have not visited. This is v of 2, this is v of 3. It's not, it is equal to 0. That's why what it will do, v of 3 is equal to v of 1. v of 3 is equal to v of 1. v of 3 का है 0 है. which is v of 3 is equal to v of 1. V of 1 is 1 is there, v of 1 is 1, so v of 3 will become 1, which indicate that v of 3 is also visited. After that, now it will going to bypass all remaining things and it will jump to here. Now cost of 1 3 is equal to cost of 3 1 is equal to 999. Okay, so again we are modifying this value. 1 of 3 will be, instead of 1 it will become 999, and 3 1 will become 999. Okay, because next time we should not consider that age as a minimum one. Now after that, minimum is not equal to 0. Yes, true. Okay, so total cost is equal to previous total cost is 1 plus new minimum value is 1. 1 plus 1 will become 2. And which vertex we have considered? Vertex 1 and vertex 3. So vertex 1 is here, you can see vertex 1 is equal to, vertex 1 is B and vertex 3 is D. So we have considered the edge as a B to D. Next time we have considered the edge as a B to D, and which cost is equal to 1. Okay, so far we have considered these two edges, A to B and after that B to D. B to D, this edge is considered. Okay, our matrix is like this and weight is 1. So far we have not considered this one actually, like this. Now again temp is equal to v of 0, which is 1 actually, flag is equal to 1. So again check whether all vertices are visited or not. So temp will start with 1, v of 0 is also 1, so 1 not equal to 1, condition is false. Next v of 1, temp is 1, v of 1 is also 1. Here you can see v of 1 is also 1, so that's why this condition is false. Now I will become 2, so temp is 1, v of 2 is equal to now right now 0. Okay na? So that's why this condition is true now, because temp value is 1 and v of 2 is 0, not equal to, so this condition is true. Now again we are making flag is equal to 0, which indicate that still we have not visited all the vertices. Here you can see so far we have not visited C vertex. C vertex is still remain. So again it will start from this flag. Now minimum is equal to 999. We are making minimum is equal to 999. After that I will be equal to 0, I less than 4, j is equal to 0, j less than 4, and cost of 0 0. Again among all these, which one is minimum? 2 is minimum. Among all these, with the help of this condition we can find out. So among all these 2 is minimum. So when I is 0, j is 3. So x will be equal to 0 and j is equal to 3. Okay na? So 2 is minimum 1. So again it will check. So x is 0 and y is 3. So v of 0, okay, here it will check. V of 0 is equal to 0. No, it is 1. And v of 3 is equal to 0. No, it is 1. Right? So that's why this will going to check else condition, whether v of 0 is equal to is not equal to 0, true, but v of 3 is equal to 0, no, it is also 1, so this is also false. Okay, so next else if v of 0 is equal to 0, no, 1 is there. Okay, this condition is false. And v of 3 is not equal to 0, true, but false true will become false. Now it will be in the else part. In else part I am checking whether v of 0 is equal to v of 3. Yes, because both having one value, so yes. So at that time minimum is equal to 0 and both vertex are visited, and if you are going to add it, then it will going to create the cycle. You can check it. If I am going to add this A to D, which having weight is 2, then what will happen? A to D is added, then it will going to form the cycle. So I am not going to add it. I am not going to add that A to D. Okay, and as well as I am making that as a 999 value, as well as I am making it as a 999 value. Means now instead of 2 it will become 999. It will become 999 here. So here and as well here. Okay na? So that age is not added. Here also you can see that. That's why we have written here if minimum is equal to 0. If not equal to 0, then only we have to do it. And here you can see we have initialized it to the 0. That's why it will not going to add that weight in a minimum cost. Okay. Again temp will be equal to v of 0. Again it will check. Okay, with same. So whether temp is 1, v of 0. V of 0 is visited. Yes, v of 0 is 1. Okay, so that's why v of 0 is 1. So this condition is false. Okay, 1 is not equal to 1. Next time v of 1. V of 1 is also 1. B is there, which is also 1. So that's why this condition is false. Now v of 2. Okay, so v of 2 is equal to 1. No, it is 0. Here you can see v of 2 right now it is 0, not visited. So that's why this condition is true. Now flag will become 0. Still we have not visited C vertex, so this is still remain. So now again it will be back here. It will be back, flag will start from 0. Now again we are going to find out the minimum. Again we are interested here to find out the minimum cost. So from remaining, which one is minimum? 3 and 4 is there, so 3 is minimum. But when b is equal to 1 and c is equal to 2. Okay, when b means x is equal to 1, okay, and column is equal to 2. So x is equal to 1 and j is equal to 2, 1 to 2. Now let's start with this one now. So it will check here. Okay, 1 to 2 and minimum cost is equal to how much? 3. Okay, cost is 3. So 1 to t. 1 to 2 is there. So it will start v of, okay, so v of 1 is equal to 0. No, this is false. So this condition is false. Now it will check next one. V of 1 is not equal to 0. True. And v of what is it? V of 2. V of 2 is equal to 0. Yes. V of 2 is 0 because we are not visited. V of 2 is 0. So that's why v of 2 will be equal to v of x. So v of 2 is equal to v of 1. V of 1 is what? 1. So this value will become now 1. So here you can see all 4 vertices are visited. But now it will going to jump to this part. Okay. So cost of 1 2 will be equal to 2 1 equal to 999. So here what we are doing? We are instead of this we are doing it as a instead of 3 here we will going to make it as a 999. Here also we will going to make it as a 999. Okay, na? Now after that as minimum cost is equal to 3, so which is not equal to 0, so we will going to add total cost plus minimum. So previous total cost was 2 plus 3, it will become 5. Okay, and which age we will going to add? We will going to add B2C. We will going to add the B2C age. B2C na? Yes, we will going to add B2C age with cost is equal to 3. Now again, so which ages we have considered? Vertex 2 to vertex 3, and that is nothing but B2C. So here we have considered the age as a B2C and weight is equal to 3. Okay. Next time again we have to check whether all vertices are visited or not. So again temp equal to v of 0, which is equal to 1. Flag equal to 1. Now temp value is 1. It will start with 0 to 4. So 1 is equal to v of 0. So here you can see all are 1 actually. All are right now all are 1. So v of 0 is 1, condition is false. Next v of 1 is also 1, condition is false. V of 2 is 1, condition is false. V of 3 is 1, condition is false. So all time condition is false, which indicate that all the edges we have considered or no any vertex are remain to visit. All the vertices are visited. That's why flag will remain 1. So it will be outside the while loop, and it will be outside the while loop. And here we are printing total cost of the tree is nothing but total cost is 5. And here you can check total cost is 1 plus 1, 2 plus 3, 5. So this is the minimum spanning tree for the graph which you have considered. If you are going to draw the minimum spanning tree for this particular graph, okay, so it will become, I am going to draw A to B, that is 1, after that B to D, that is 1, and finally B to C, that is 3, and total cost is 1 plus 1, 2 plus 3, 5, and all vertices are visited. So in this way you can calculate the minimum spanning tree. And finally in the main function just you need to call all those methods like create graph, display graph, and finally display the with the Kruskal algorithm display the minimum spanning tree. So in this way you can calculate the